like to introduce KYZEN's own Ethan Mueller.
Thank you, Sherry. Good morning and welcome to today's Tech to Tech session. Our topic, acid to alkaline cleaning agents and where do they fit? And this is really an interesting question when you are in the cleaning realm. Generally speaking, when you're looking at a cleaning product lineup, they're broken down into categories, generally based off of the pH scale, and those categories break down into acidic, neutral, mild alkaline, and alkaline, and we can kind of generalize what their applications are. From acidic to neutral, we're typically using these products for surface preparation, and for neutral to alkaline, we are generally using these for surface cleaning. So when it comes to cleaning agents, they're mostly alkaline. And why is this? And really the reason is because the alkalinity provides us with the chemical action that we need to do the cleaning, to remove a lot of common metalworking contaminants. Oils and greases, they are actually hydrolyzed by alkaline products, which forms a water-soluble salt, allowing us to easily rinse the oil or grease away from the surface of the part. Another reason that most cleaning agents are alkaline is because a lot of the mechanisms that we rely on to clean our parts are more favorably carried out at a higher pH, things like deflocculation, dispersion, emulsification. And finally, some of the additives that we're relying on to clean our parts, they're not soluble at lower pHs, so we need to add those to an alkaline environment to get them into solution. So when we're talking about alkaline cleaners or our heavy-duty alkaline cleaners, these are the products that typically fall in that pH scale of 12 and up. They're alkaline. They're built up with alkaline salts like caustic soda or caustic potash, which is a strong base when you add it to water. And these are heavy-duty cleaners. These are for removing heavy soil loads, heavy amounts of oils and greases. But they're not good for cleaning soft metals. So for cleaning something like brass or aluminum, we're going to want to steer away from these products. That leads us to the mild alkaline cleaners. These are the products that fall in that pH range of 10 to 12. And they're built up with mild alkaline salt builders, typically silicate salts or something like this. And those silicate salts inhibit the attack on our soft metal. What they're doing is they're providing a protective barrier to the metal, simultaneously giving us that alkalinity that we need to clean. Neutral cleaning products, these are those products that fall in that 6 to 8 pH range. And these are generally more marketed to be EH&S friendly. This is when you're trying to win EH&S approval or something like that. But these products are built up with chelators and other additives like wetting agents or surfactants to help us clean our parts. And they're really more geared towards removal of light oxides or light oils and greases. These products tend to have a short bath life. So they're really not for somebody who has a high throughput on their manufacturing line or is removing a lot of oil and a lot of grease. This is really a light duty cleaner that is more geared towards being EH&S friendly. So getting into the acidic side of the spectrum, these are the products that tend to fall in the pH range of 1 to 4. And we're really relying on these for rust and oxide removal, removing scale from our equipment. And because acids tend to react with our base metals, we rely on these to do conversion coatings such as passivation, pickling, or phosphating. So rust and oxides. What are rust and oxides? Really, it is the oxidative state of the base metal. So your metal has reacted with the oxygen in the atmosphere, forming this oxidative state. Sometimes this is desirable or not problematic. Other times it's going to impact our downstream processes, such as our plating processes or our painting processes. So we want to remove them to give us a nice active metal surface. And we call upon acids to do this. The acids react with that oxide layer. They form a water and a metal salt, and that metal salt allows us to pull that rust away from the surface of the part. Ferrous parts, they tend to be pretty resilient to acid. So we can use a stronger acid, if you will. Phosphoric acid is common to see with steel or ferrous parts. Soft metals tend to be more susceptible to acids, so we want to use a more mild acid or a higher pH acid, if you will. Citric acid is pretty common for use of some of the softer metals. Scale. Scale occurs in our plumbing. It is from the minerals that are dissolved in our groundwater. And if we're dealing with RO or DI water in our cleaning process, we're probably not battling this. But the guys in water treatment probably are dealing with it a little bit. But really what that scale is it's carbonate or bicarbonate buildup. And it's depositing in our plumbing, in our equipment tanks, on our heaters. And we can react this with acid. And acid reacts with scale to form CO2, water, and a soluble salt. And because we're forming that soluble salt, we can easily rinse that away from our equipment and get it out of there. Mill scale is not scale in the general sense. It is the flaky surface seen on hot rolled steel. And this is a form of oxidation, also known as rust. So we can remove that in similar ways that we are removing rust from steel parts. Conversion coating, acids react with the surface of the metal. So we use it for conversion coating, such as stainless steel passivation. This is where you are relying on an acid to come in and remove any free iron from the stainless steel surface. Typically, that iron is impregnated there by machining or tooling, if you're grinding on weld seams or something like that. So we rely on acid to come and remove that iron ion from the surface. It also promotes the chromium oxide layer, growth of the chromium oxide layer, which is what gives stainless steel its corrosion resistance. Steel parts phosphating, this technically is not conversion coating, but it often falls under that category. And what happens here is you're using phosphoric acid, and that phosphoric acid is reacting with your part. It creates an iron phosphate salt. And because the acid at the part interface, at the surface of the part, is being consumed, the pH starts to rise. That allows the phosphate salt to precipitate out of solution and deposit on our parts, giving us a phosphate coating, whether we want that for lubricity or corrosion protection or maybe paint adhesion. There's a few different reasons you would want your steel parts to be phosphated. Of course, we're also using acids in other electrolytic processes, any type of plating, or maybe aluminum anodizing. Something worth mentioning, it's a little bit of a misnomer to categorize cleaners by their pH. There is a lot more that goes into them. Chemical companies rely on many different blends, many different additives, and a ratio of these additives to really give us the cleaning the cleaning that we're looking for. And so we're using all sorts of additives such as wetting agents, emulsifiers, surfactants, saponifiers, chelators, solvents. There's all sorts of stuff that goes into these cleaning products that goes beyond the pH. The consideration when you're choosing a cleaning product, really understanding what your equipment is, how that's going to impact your throughput, how it's going to impact your cycle times, maybe exposure to the operator. These are all important things to consider. Your equipment really has a lot to do with your cleaning process. Compatibility. This is something that you really want to consider when you're dealing with soft metals. And hopefully your chemical vendor would know a lot about this, so you don't have to do a lot of legwork. They just know upfront whether their product will react with your metal or not. But once again, that's definitely something that you want to take into consideration when you're looking for a cleaning product. And of course, we are always concerned with the environment and the health and safety of our operators. Not all acids and bases are created equally. Some, when you get them on your skin, you have some time to go and neutralize that acid or base. and get it away from your skin. You might have a little bit of a burn or a red mark. Other acids and bases, as soon as they touch your skin, you have a burn. There is no recourse. Of course, you do still want to neutralize that acid or base and get it off your skin, but you have a chemical burn. So you will see sometimes EH&S people choose one product over another simply because of the safety factor. So in summary, acid and alkaline solutions serve many, many functions in the metal industry, well beyond the scope of what we were talking about in this tech to tech. But when it comes to cleaners in general, acid products are used to prep metal surfaces. This means removing scale, or removing rust, or removing oxide, as well as conversion coating. Um, and alkaline products are generally used to clean metal surfaces, whether this be removing oils or greases or other dirt and grime. Um, and then finally, just to mention neutral products once again, these are really geared towards light duty cleaning and are kind of more for appeasing our EH&S people. If we have a lot of throughput or we're removing a lot of oil, these are really not the products that we should be thinking about. With that, I would like to thank everyone for joining this Tech to Tech today, and I will turn it over to Sherry with any other questions.
Great. Thank you so much, Ethan. If you would like to discuss this topic further, please contact your local KYZEN representative or send an email to tech@KYZEN.com, and we will have one of our cleaning experts schedule a follow-up with you as soon as possible. Again, we thank you all for joining us today, and we hope to see you again soon. Stay safe, stay healthy, and have a great day.